Hi, fourth graders. We're back for our second week of remote learning for my in-person remote learners, and then my two kiddos that have been remote learning. We're picking up where we left off on I think we're on week 10 for our remote learners, and then week 2 for our my in-person learners who are learning from home right now. So what I'm going to need you to do is have your papers out. You're going to need your Module 3 Lesson 2, and it starts on page 57. We're just doing Module 3 Lesson 2 right now, so those are the only papers you need. Please do not go ahead. Please do not do any papers other than what is assigned on the day that it is assigned. If you try to go ahead without following the lesson and going through with the teaching piece of it, I'm just worried that you might miss out on something, or you might learn something possibly incorrectly. So please, please, please stay with me and only do the papers as I push out these lessons, and follow along with the video with me. Okay? So you're going to need Module 3, Lesson 2, and it starts on page 57. So I'm going to switch my camera down so that way I'm on the book, and so that way you can follow along with me in the book. Okay, get us so we're the right direction. And you can see that Module 3, Lesson 2, that's what this one looks like. We have this hexagon right here. So this lesson is distinguishing between multiplicative and additive comparisons. And that just means we're trying to figure out whether we need to multiply or add when we're doing our comparisons. So multiplicative means multiply, and additive means add, right? Or addition. So we're trying to figure out, when we read our word problems, do we need to compare by multiplying, or are we comparing by adding? And that's really all this is about. Multiplying or adding, and what comparison are we using? So when you're done, you're going to be able to identify and represent multiplicative and additive comparison problems. So multiplying or adding comparison problems, or combining the two in the problem, but figuring out what you need to do, whether you need to add or whether you need to multiply. So let's look at this first problem where we have our hexagon. And remember, hexagon is a 6-sided shape. 1, 2, 3, 4, 5, 6, right? So that's a hexagon. Chenille makes a hexagon using 6 toothpicks. Rachel uses 2 more toothpicks than Chenille to make a shape. Leo uses 2 times as many toothpicks as Chenille to make a shape. Use a visual model to show the number of toothpicks Chenille, Rachel, and Leo each use. Oh my goodness, I'm not sure about you. When I first read that problem, wow, it's really confusing me. So I need to go back and reread that problem and see if I can figure out, because I've got 3 people and they each have a different number of toothpicks to make their hexagon. Or to make their shape. So this first sentence talks all about Chenille. Chenille makes a hexagon using 6 toothpicks. I'm going to start with Chenille. I'm not even going to worry about Rachel or Leo yet. I know that Chenille, she's making a hexagon with 6 toothpicks. So I'm just going to make 6 little squares right here for my picture. 1, 2, 3, 4, 5, 6. So I know she's using 6 toothpicks. Now let's go back to our problem. Rachel uses 2 more toothpicks than Chenille to make a shape. 2 more toothpicks than Chenille. So I have Rachel. Rachel is using 2 more toothpicks. So what do you think that means? She's going to have 6, right? Because she's got the same as Chenille, but with 2 more than Chenille. So here's her 6, and she needs 2 more. So is that adding or multiplying? I hope you said it was adding. So Chenille started with 6, and Rachel has 6 plus 2. So Rachel has 8 toothpicks. So we've got Rachel with 8, Chenille with 6, and now we have Leo. Leo uses 2 times as many toothpicks as Chenille to make a shape. 2 times as many. Times as many. There's a word in there that should be giving you a clue. Times as many. Doesn't that sound like we need to multiply? Because when we multiply, we times, right? 3 times 4 or 7 times 8, right? Use that word times. So we're going to be multiplying. So for Leo, he has 2 times as many. So here is 1 time, right? But he has 2 times as many. So I need to do another group of 6. And here is our second time. So he has 1 group of 6 and 2 groups of 6. So this one, he is multiplying. So 2 times 6. And 2 times 6 equals 12 toothpicks. So Chenille had 6 toothpicks. Rachel had 2 more than Chenille, so you needed to add for hers. And then Leo had 2 times as many as, so you had to multiply for Leo. So he has 12 toothpicks. Sorry, my book was down too low. I apologize for that. So the words in your word problem are really going to be what you need to be paying attention to decide whether you need to add or you need to multiply. So let's go to 58. We're going to build for some understanding. Get my camera so it's not so fuzzy. All right, Victor is going to make 4 paper cranes. Natalie makes 3 times as many cranes as Victor. How many paper cranes does Natalie make? So what clues in this problem are going to help us figure out what we're going to need to do? The clues are this times as many, right? So we're going to make our picture. We're going to use our visual model just so we can make a picture to show. So we know that Victor makes how many cranes? Victor's going to make 4 cranes. Right? It tells us right in the problem. This is exactly how many cranes he is making. And then Natalie makes 3 times as many cranes as Victor. 3 times as many. So how many groups of 4 do I need for Natalie? I hope you are thinking or said out loud that we need 3 groups of 4. So 1 group, 2 groups, 3 groups. So what multiplication equation would I write to solve the problem for how many paper cranes Natalie makes? I know we have 3 groups of 4. So 3 times 4. 3 times 4 equals 12. So Natalie makes 12 cranes. So how can you use an equation to model the number of cranes Natalie makes? We just did. This is our equation. We just figured it out. We're going to use multiplication. So 3 times 4 equals 12. And the second question says, how many does she make? Well, she makes 12 cranes. Now letter B. Suppose James comes in And James makes 3 more cranes than Victor. 3 more cranes than Victor. What equation can you use to model the number of cranes James makes? So will this be an addition or a multiplication problem? 3 more cranes means we are going to add. So if Victor made 4 cranes, then James made 3 more. So 4 plus 3 equals 7. So James makes 7 cranes. So how are these two equations different? Well, we multiplied when it wants times as many as, and we added when it just wants more. So I'm just going to shorthand this. Multiply equals when we see that times as many. And we added when we saw just the word more. So those were kind of our clue words, right? Those were kind of the words that gave us the hint that told us how we needed to solve the problem. All right, so now on to page 59. We're going to step it on out. We've got these cute little peacocks over here, and Maria makes a peacock with 8 feathers. See her 8 feathers there. Simon uses 4 more feathers than Maria. Ooh, there's that word more. Does that clue you in to think what you probably need to do? Complete the bar model to show the problem. So we know that Maria used how many feathers to make her peacock? She used 8 to make her peacock. And then this little thing just means how many more were used. So we know that Simon used 4 more. And Simon is our N. Simon is our unknown. When we remember, we talked about how we use a letter to help us decide when it's our unknown. That's what we need to put in there. So this is a more problem, which means this is an addition problem. So we know that Maria started with 8 feathers, but Simon, he's like, no, I'm going to put 4 more in there. I want my peacock to be a little fuller. So I'm going to add 4 more. So 8 plus 4 equals 12. So Simon is going to use 12 feathers. Now, Desiree comes in, and she really wants hers full. She's going to use 4 times as many feathers as Maria. How many feathers does Desiree use? So there's that times as many. Remember, we talked about that over here. When I see those words, times as many, that's a clue to multiply. When I see the word more, it's a clue to add. So my clue says times as many. So I have first, how many? They're comparing Desiree with who? Maria. And Maria did her peacock with 8 feathers. So here's Maria, and she has 8 feathers. And then this bar model is going to be for Desiree. And she did 4 times as many. So we need 4 boxes with 8 in each box, right? And then our N is our unknown. We need to figure out how many she used. So times as many is a multiplication equation. So how many groups? There are 4 groups of 8. So 4 times 8 equals N. What is 4 times 8? I hope you said 32. So Desiree uses 32 feathers. Nice job. All right, so let's check for some understanding. So Ming mixes 2 cups of red paint with white paint. She uses 4 more cups of white paint than red paint. How many cups of white paint does Ming use? Is this an additive or multiplicative comparison problem? and explain how you know without solving it. Oh my goodness, so we're not going to solve this. So let's explain how we know. Well, let's look at this first. So let's read this again. Ming mixes 2 cups of red paint with white paint. She uses 4 more cups. I'm going to underline my word, my clue word, of white paint than red paint. How many cups of white paint does Ming use? Is this an additive or multiplicative comparison problem? And explain how you know without solving. So first of all, more tells me I am going to do what? Am I going to multiply or am I going to add? Remember when we talked about it over here? Multiply, my keywords I'm going to see are times as many. When I add, my keyword I'm going to see is more. What keyword did I see over here? And I already boxed it in. More. So this one is an additive problem. And then, how do we know that? We know that because it says that she uses used or uses 4 more cups of white paint than red paint. There were nowhere in this problem did it say times as many, right? So we know it's not a multiplication problem. It is an addition problem. Now I know it said explain how you know without solving, but let's figure this out. How many cups of white paint did she use? Well, we know she used 2 cups of red paint and she used 4 more cups of white paint. So 2 plus 4 equals 6 cups. I'm just solving it just because I don't like to see a word problem without the solving. I know it said we didn't have to solve it, but I like to solve them. Okay. So now we've reached the part where it's on your own. There's 3 problems here to solve independently. What you can do, this is what I've been doing all along, is you can either pause your video right here, do them on your own, and then come back to the video to check your answers, or you could just stay with me and do these problems right along with me. Whatever you feel the most comfortable doing. Okay? So number 2. Corey makes these finger puppets. Jackie makes 6 times as many puppets as Corey. How many puppets does Jackie make? Is this an additive or multiplicative comparison problem? Explain how you know without solving. Alrighty. Let's read this problem again. I want to double check I'm hearing it correctly and I'm reading it correctly. Corey makes these finger puppets. So let's see, how many puppets did Corey make? Corey made 4 finger puppets. So I'm just going to write that up here. Corey equals 4 finger puppets. Because I can see that in the picture that there are 4 puppets. Jackie makes 6 times as many. Oh, there's that phrase. That's a big clue. 6 times as many puppets as Corey. How many puppets does Jackie make? Is this an additive or multiplicative comparison problem? And explain how you know without solving. So this is very similar to the problem previously, right, that we just did. So is this additive or multiplicative? Are we adding or multiplying? I hope you're either thinking in your head or you said out loud or you wrote down multiplicative. Because we are multiplying. It's a multiplicative comparison problem. And why do we know? Well, here's our clue, right? It says, so the problem says that Jackie makes 6 times as many puppets as Corey. 6 times as many, right? That times as many puppets as Corey is going to be our clue that we need to multiply. So how would we solve this problem? Let's just solve it just to do it. So we would have, Corey had 4 puppets. Jackie had 6 times as many. So 4 times 6 equals 24 puppets. Number 3. Jen takes 6 minutes to make a paper animal. Brian takes 5 more minutes than Jen to make a paper animal. Kai takes 5 times as many minutes as Jen. How many minutes does it take Brian and Kai to each make a paper animal? Write an equation to model and solve each problem using n for your unknown. All right, so we read it through once. Let's go back and read it again. And we're going to underline our clues to help us understand what we need to do. So Jen is going to take 6 minutes. So I just want, that's our baseline, right? That we know everybody's going to be going by Jen for this problem. Now other problems may go by somebody else, but for this one, it's both Brian and Kai are going to be comparing with Jen. Brian takes 5 more minutes than Jen. 5 more minutes than Jen to make a paper animal. So are we going to add or multiply to figure out how long it takes Brian to make a paper animal? That more word clues me in that we need to add. So 6 plus 5 equals, remember we're using n for the unknown, equals n. How are we going to solve this? Well, we know that 6 plus 5 equals 11. So n equals 11. So Brian takes 11 minutes. Because we need to write an equation and solve each problem. So our equation was 6 plus 5 equals our unknown, which was n. N equals 11. So that means it takes him 11 minutes to make a paper animal. Now let's go back and look for Kai. Kai takes 5 times as many minutes as Jen. 5 times as many minutes. So times as many tells me we need to multiply. So 6 times 5 equals, and we again need to use our n for our unknown. So our n equals what? Our 6 times 5 equals 30. So it takes Kai 30 minutes to make a paper animal. Okay? All right, in our last problem, we're going to be using our bar model to help us solve this one. And this time we're going to be using C for our unknown. Hassan mixes 2 cups of water with oil to make a lava lamp. He uses 3 times as much oil as water. How many cups of oil does Hassan use? Use the bar model and write an equation to solve the problem. Use C for the unknown. Alrighty, so let's start from the beginning again. We're going to reread our problem. Hassan mixes 2 cups of water with oil. So we're going to start with our water, and there are 2 cups of water. And that 2 cups of water is mixed with 3 times as much oil as water. 3 times as much oil as water. So there's more water or oil? There is more oil. And it's 3 groups of 2. So what would our equation be to solve this problem? Are we adding or multiplying? We are multiplying. So I know we have 3 groups of 2 equals our C for our unknown. Or sometimes we use a letter for our unknown. So 3 times 2 equals what? C equals 6. So Hassan uses 6 cups of oil. Alrighty, so that is the end of Module 3, Lesson 2. What I would like you to do now is complete the black and white paper that is directly after this page. Do not move on to this. Stay and go to the black and white paper. When you are finished, please take a picture of the front and the back and forward it to me. Either your parents could maybe take, or some grown-up at home could take a picture of the front and the back and send it to me through my email. That would be great, so that way I have a copy of it, because now that we're not coming back to school until January, I don't want a huge stack of papers to come back in January. And we were talking with Mrs. Calnan the other day, and she did not think that we might possibly even be able to take the papers back to school. So I think it would be just the easiest thing for you to do is to take a picture and email it to me, and then I have immediate proof that you have watched the video, done the work, and completed the worksheet page that goes along with it. So please complete lesson 3.3, the black and white 3.3 worksheet. Take a picture of the front and the back and forward both pages, the pictures of both pages, to me. All right, I will see you soon. Bye, everybody.